So the topic of this video is tangent lines of circles, and our objectives: I can define and identify a tangent line, and I can state and understand the properties of tangents. Okay, and just a quick review. A tangent is a line in the plane of a circle that intersects a circle in exactly one point. So here we have the green line is our tangent line, and we can see that if we kind of make a point right here, that this is, we'll try it this way, we can make a point right here, that this point is where it intersects the circle. Okay, now we talk about coplanar circles, and what coplanar means is that they're in the same plane. So, and the plane is just either, the sheet of paper or on your screen. It's in two dimensions. We're not dealing with 3D shapes. Okay, and in one plane, two circles can intersect in 2 points. So we can see these circles intersect here and here. Those are our 2 points. They can intersect in 1 point. Right here, these two circles intersect in this 1 point. And right there, and these would be called tangent circles. Understand tangent line intersects at 1 point. So tangent circles intersects at this 1 point right here too. And then they can intersect, they can be no intersects, they can just be like this. And then the last is concentric. And concentric circles mean that two circles share a center. And so they can be like this, one circle inside the other, or they could end up, being the same circle. Okay, and now if we talk about common tangents, like we saw, the one where they meet at one place, we have a common tangent, which is a line, ray, or segment that is tangent to two coplanar circles. So right here we have common tangents, and this one is called internal because we see it meets on the inside, I guess, of where the two circles would be, right here. And then external, see, it's on the outside of two circles. It's not in between here. Okay. So, just a quick review here. We want to determine how many common tangents these pairs of circles have. So if we look at the first one, we can see that it has a common tangent here. They have a common tangent here as well. Those are two external tangents. Then we can see that there's a couple of internal ones as well that share that tangent here. And then lastly, one right there. So these two circles actually have 4 common tangents. The second pair, again, we have these two outside. Let's try draw another one of those. We have there, that's a better one. This common tangent here. We have another one right on the outside of them. And then we have the one that they share in the middle. So these have 3, try that again, 3 common tangents. And then these last pair of circles have the one on the outside here, and then the other one on the outside. And that's it, because we can't do anything internally because the two circles are intersecting. So this one, these set of circles, has 2 common tangents. Okay, move on to a theorem. So tangent segments that come from a common external point are congruent, and this external point just means that it's a point not inside the circle and not on the circle. So it's got to be outside of our circle. So if we say that RS and RT are both tangent to our circle C, because that's our center, they both come from this external point R. So they are congruent, so we can solve for x. So if we set that up, we have 28 equals 3x plus 4. If we subtract the 4 over, we get 24 equals 3x. Divide by 3 on both sides, that's a 3. Then we get x equals 8. Okay, second theorem. In a plane, a line is tangent to a circle if and only if the line is perpendicular to the radius of the circle at its endpoint. So the tangent line has to be perpendicular to the radius. Right here we have to, oops, let's try that again. Right there we have a right angle, and so it'd be perpendicular there. And we want to know if AB is tangent to circle C. So to determine whether segment AB is tangent to circle C, we have to show that this is a right angle. And to do that, we have a triangle. And if you remember back to our triangle unit, if a squared plus b squared equals c squared, then we know we have a right triangle. If a squared plus b squared was less than or greater than, we would either have acute or obtuse. But if they equal each other, then we have a right triangle. So to check this, we have our 3 side lengths, we have our 2 legs, and our hypotenuse. So we would have 4 squared plus 3 squared. Set that equal to 5 squared. Oops, that's a 5. Let's try that again. 5 squared, there we go. So 4 squared is 16. 3 squared is 9. Set that equal to 25. 16 plus 9 gives us 25. So 25 equals 25. That is true. So we can say AB is tangent to our circle C, because we have created a right angle, so the tangent line is perpendicular to our radius. Another example, we say AB is a radius of circle A, and we want to know if BC is tangent to circle A. So if we want to show that BC is tangent to A, we have to show that triangle ABC is a right triangle. So to go about that again, we just set our a squared plus b squared equal to c squared. So take 25 squared plus 60 squared equals 67 squared. 25 squared is 625. 25. 60 squared is 3600. And 67 squared is 4,489. So 625 plus 3,600 gives us 4,225. And since that is not equal to 4,489, BC is not tangent to circle A. Okay. Now we say B is the point of tangent C, and the point of tangent C is just that one point where our tangent line hits or intersects the circle. So B is at the point of tangent C, so we are saying that segment AB is tangent to circle C, and we want to find the value of R, and R is just our radius here. So to find the value of R, we have to set up our formula using Pythagorean's theorem. So we have 4 squared, because that is one leg, plus the other leg is R squared equals, and then this hypotenuse here, this length, is 2 plus R, so we have 2 plus R squared. That is 8. There we go. So if we do this math, 4 squared is 16, R squared, simply R squared. Then 2 plus R squared is the same as saying 2 plus R times 2 plus R. A little review from geometry. So we get 16 plus R squared is equal to 2 times 2 is 4. 2 times R is 2R, plus another 2R gives us 4R. And R times R is R squared. So here if we subtract 4 on both sides, and also subtract an R squared on both sides, 16 minus 4 gives us a 12. R squared minus R squared, these two are gone, and we're left with 4R. So then we divide both sides by 4, we find R equals 3. And that makes sense. If we were to plug 3 in for R, we'd have this side equals 3, 2 plus 3 is 5, and we have one of those Pythagorean triples. So now to review, tangent segments from common external point are congruent. That was one of our theorems. And in a plane, a line that is tangent to a circle, or a line is tangent to a circle, if and only if that line is perpendicular to the radius of the circle at its endpoint on the circle. So at that point of tangent C, the tangent line and the radius have to be perpendicular. So we have this, we have to have that right angle there. Make sure to go online, do your reflection, answer those questions, get your bonus point, ask any questions you might have, and we'll see you in class tomorrow.